Welcome. In this session in linear data analysis, we'll go through the organization of the course. The course format is that every week there will be recorded lectures, such as this one, on the Lightboard, and I'll sometimes use electronic overlays, such as MATLAB. We'll have two synchronous classes every week, and these will be mainly tutorials. I call them super tutorials because they're tutorials that go beyond the usual level of tutorial. These are basically problem-solving sessions. I'll be presenting one of them, and one or more TAs will be presenting in the second of these synchronous days. The third synchronous class for each week will be some form of assessment. It will be either non-credit homework that you can do, an assignment, or a test. There are 12 weeks in a Queen's University semester, and there are 5 assignments and 5 tests, so almost every week you'll be going through some form of assessment. The homeworks you can think of as a form of self-assessment. And these will be broken up into 4 modules of 3 weeks each. In the first module, what we'll do is we'll go over some of the prerequisites that we expect you to understand before you begin this course, and I'll explore some material that you may already know about, but we'll put it in a new format. So what I'll do later in this lecture, this is just one session in the lecture, I'll go through some things that I call eigenfacts. And then what we'll start doing is we'll start looking at graphs. So graphs are an idea that you may have come across from discrete mathematics. And what we'll do is we'll represent graphs using matrices. And the idea in this is we'll take some of the related knowledge you have and we'll start exploring how to use matrix notation to express and solve problems in this related stuff. Then weeks 2 and 3 of the first module are going to be special matrices. These will be a combination of mathematics and MATLAB computations. These will be basically vector spaces, and we'll start on spectral decomposition, which is a really key concept in this course. And the idea behind all of this material is what we want to do is start analyzing matrices by the properties that they have. In the second module, what we'll begin doing is linear regression. You probably already know something about linear regression. We're going to view it as a problem of projecting a vector into a vector space. And we'll explore how we can look at cross-validation of linear regression, which is one way to assess the quality of a linear regression. The goal in this is you probably already know how to perform, and now we're going to learn how to assess linear regression using some concepts that you can continue using if you go to graduate school and beyond. Week 5 and 6 will concentrate on perhaps the most important theorem in linear algebra from the 20th century, which is the singular value decomposition. In this, we'll start to take some of the material from the first module and we'll start to be able to express it and compute it in a new, powerful way. And this will let us explore things such as how can you approximate one matrix with another matrix, where the first matrix may have a very complicated structure and the second one has a much simpler structure that you know. And the goal in this is now to analyze not just a matrix and its properties, but to analyze the structure of a matrix. In the third module of this course, we'll look at one of the fundamental ideas in linear data analysis, which is principal components analysis. This is a way to take a high-dimensional problem, one that, for example, might have 1,000 variables, and reduce it to one that has only 2 or 3 variables. This is closely related to the concept of the singular value decomposition, and it's actually how it's computed in practice. The goal in this is to learn this fundamental method for analyzing data. Then we'll begin our exploration of machine learning, and we'll use one particular way of assessing it. So what we'll do is we'll explore unsupervised learning, which is also called clustering, and of course, because this is linear data analysis, we'll look at linear objects, which are vectors. We'll start to learn data, learn how to express data, and learn how to classify data by exploring this idea of a hyperplane, which is a plane in a high-dimensional space. The confusion matrix and the ROC curve, which is the receiver operator characteristic curve, are how we'll look at assessment. So out of this, what we'll do is we'll learn how to assess supervised machine learning in a way that is common in not just graduate courses, but a lot of current research. In the last module for this course, what we'll do is we'll begin exploring machine learning from a linear point of view. So we'll start by looking at artificial neurons and very, very simple neural networks. We'll see what logistic regression is for labeled data and how that relates to artificial neurons. And then we'll start taking the scores that you get out of regression or out of artificial neurons, and we'll start seeing how we can convert those to probabilities. This will be a bridge. This will be a way that we can now begin to think about nonlinear data. And the goal is we want to be able to formulate and solve problems that commonly arise whenever we have to analyze data. So the basics of this course are the primary emphasis that I have is what methods are commonly used for linear data analysis. We'll explore some of their strengths and weaknesses, and in particular, I'll give you my extensive empirical experience with some of these methods. A secondary emphasis in this course is how you actually implement these methods. Some of them are so complicated that we rely on libraries. So that's what we'll be doing in this course. Let's get to work.